Your phone can find a similar photo across your entire camera roll in under a second. Thousands of images, compared instantly. It's not checking every single one. So what is it actually doing? By the end of this video, you'll understand exactly how vector databases perform near-instant similarity search across billions of items, and why this technique is the invisible engine powering every AI product you use today. Traditional databases are built for one thing: exact matches. You ask for rows where name equals Alice, and you get them instantly. But what if you don't want an exact match? What if you want something similar, a photo that looks like this one, a product that feels like that one, a sentence that means roughly the same thing? Traditional databases have no answer for this. They're fast at finding exactly what you asked for, but completely blind to what you meant. That gap between precision and meaning is the entire reason vector databases exist. And it turns out, closing that gap requires rethinking how search works from the ground up. But here's what most explanations skip entirely, and it's the reason you can't just bolt similarity search onto a regular database. When an AI model processes text, an image, or audio, it converts that input into a vector, just a list of numbers. Maybe 768 numbers. Maybe 1536. And here's the insight that makes everything else work. Similar things produce similar number lists. The vector for the word dog sits mathematically close to the vector for puppy. The vector for a photo of a sunset clusters near other sunset photos. These vectors live in what mathematicians call a high-dimensional space. You can't visualize 1536 dimensions, but you can reason about distance in it. And proximity in that space means similarity in meaning. That's the foundation. Every trick that follows is built on this one idea. Now this is where it gets genuinely counterintuitive. The numbers I'm about to share will seem wrong at first, so you have a query vector. You want the most similar vector in your database. The obvious approach: compare it against every single stored vector, calculate the distance to each one, find the smallest. That's called brute force search, and for small datasets it works fine. 10,000 items? No problem. 1 million items. You're already looking at hundreds of milliseconds per query. 1 billion items, which is where real AI products live, and you'd need minutes per search. That is not a product. That is a broken product. The math is simple. Distance calculations scale linearly with dataset size. Double the data, double the time. There is no shortcut inside brute force. You have to leave it behind entirely. Most people hear approximate and assume lower quality. That instinct is completely wrong, and the reason why reframes how you think about accuracy in search. The breakthrough insight is this: you don't need the exact nearest neighbor. You need something close enough. Approximate nearest neighbor search, ANN, trades a tiny slice of accuracy for orders of magnitude speed. In practice, you get back the correct answer 95 to 99% of the time, in milliseconds instead of minutes. The most widely used ANN algorithm today is called HNSW, Hierarchical Navigable Small World. The name sounds intimidating, but the core idea is elegant. Instead of scanning every point at query time, you build a smart navigational structure at index time. A map, not a list. When a query arrives, you traverse the map instead of scanning the data. Here's something almost nobody talks about. HNSW was published in 2016. The fact that it still dominates vector search in 2025 tells you everything about how right that original idea was. HNSW builds multiple layers, stacked on top of each other. The top layer is sparse, just a handful of nodes connected by long-range links. Think of it like an interstate highway. The bottom layer is dense, every node connected to its close neighbors, like a neighborhood map. When a query comes in, you start at the top layer. You take the highway, jumping quickly toward the right region of the space. Then you descend, layer by layer, into progressively finer detail. By the bottom layer, you're zoomed in on exactly where your answer lives. The whole traversal visits a few hundred nodes. Not a billion, not a million, a few hundred. That is why vector search feels instant even at massive scale. We opened with a question: how does your phone compare thousands of photos in under a second? Now you know. It's not checking every image. It's navigating a layered graph, descending from highways to neighborhoods, arriving at the right answer after visiting only a tiny fraction of the data. Vector databases are the invisible engine under Spotify's recommendations, Google's image search, and every AI assistant that understands what you mean instead of just what you typed. If this clicked for you, the next video covers how embeddings actually get created. and why the model you use to generate them matters as much as the database you store them in. That one's worth watching before you build anything. I'll see you there.